Hello, welcome to the Grand Challenge Testbed at University of California, San Diego. As some of you probably remember, we had this tour last year, and I'm going to try to guide you on what's going on this year, and I'm going to try to tell you what has changed since the last year. So the first thing that has changed since last year, if you pay attention, the lab is organized very specifically along the notion that there are workstations. So this is one workstation, and this workstation hosts one semi-permanent project. The student or postdoc or scientist is free to do whatever he wants to do over here, and he has the ability to bus himself to a major piece of instrumentation or other setups as he grows. Last year when we talked to you, we had 6 of these workstations. This year we have 12 of these workstations, anticipating people participating in a Grand Challenge Testbed. So as we go along, I will tell you more specifically what's happening. For example, to your right end, you're going to see a workstation that has been now in a build-out. This is advanced coding setup that will help us both with interconnect to wireless and interconnect to data centers that is going to be part of ERC activity. Then to your right side, this is a setup that you have seen from the last year. This is a setup that is going to characterize the fibers so precisely that we will be able to do frequency generation. And as we move along, the new things that you have not seen the last time is the setup that is doing signal processing that is shared between ERC and Defense Advanced Research Project Agency. As we are building the ERC Grand Challenge Testbed, we are essentially attempting to keep at least 2 workstations empty at all the time so we can respond to requests to come here and start building on weeks' notice. So essentially, desired response time by September will be that somebody can come and start something in less than a week. So as we progress, this is an example of such an empty station that people will come and use at a week's notice. There will be at least 1 slot open at all time. And as we continue, you will see now how the fully operational integration of 2 workstations look like. For example, this setup here is currently performing ERC work on multicasting or wireless signal to 40 lambda copies. And as you can see, 2 workstations have been integrated into one setup using a bus. And also, since we are forcing a time sharing of major equipment, it has attracted most of the capital equipment during this measurement. For example, 50 gigabit per second bit error rate system, $1 million setup, is serving this station, and then all high-end measurement equipment that we have here is serving the setup at the time. And the commitment to this setup is made through the end of the next week. Speaking of equipment, we have new capital additions since we talked to you last time. For example, the lab has introduced first integrated terabit per second, or terahertz if you want it better, optical oscilloscopes. This is the first acquisition of this kind at university in US. Then laboratory has also taken 2.5 micron optical spectrum analyzer. It is going to be a key component for wireless to fiber interconnect work that is shared between Professor Coopers, Professor Ford, and Professor Papen. You will probably have a chance to hear more about this project at the poster session during the meeting of ERC. Here you're going to see the meeting that is collaboration between Professor Papen and Professor Ford that is working on advanced coding for interconnect work. So Professor Papen is conducting research here on advanced wireless-like codes in which his students, with help from ERC staff here, is trying to bring a new generation of MLSE codings that will be applicable to interconnect work that is being funded through ERC. As we slowly move deeper into the lab, you will also see a project that is jointly sponsored by ERC and Lockheed Martin Corporation that has to do with this free-space communication, and motivation is very simple. We will enable tower-to-tower wireless communications, free-space communication for wireless purposes, but we will also satisfy Lockheed Martin's desire to have free-space handheld man-to-man communication. So in that extent, we are building a transceiver that can operate between 1000 and 2500 nanometer that is being set up over here. And since this is a test bed, the entire construct is being pipelined across the bus, deeper into a free space section of the lab. There is collaboration between myself, Professor Coopers, and Professor Ford into a section of the lab that can support safe free space communication. If you remember from the last year, we had a section of the lab that can be cordoned off to satisfy full measurements of free space communication links. And if you zoom in over here, we'll see a telescope. This is a steerable MEMS telescope that Professor Ford is doing for the first time. So the main idea is the testbed facility will provide arbitrary band signal processing signal to be piped into this one. It will be sent out of a fiber into the target that you cannot see behind. The target will act as a mirror, come back and act as a free space link until we develop this to the second stage. And the second stage would be that we take this up on the roof of the building and set up communication link with the different building to simulate node-to-node wireless link to satisfy both Lockheed Martin's and ERC goals. Dramatical addition to the lab, both in a context and substance from the last year, is we have finally introduced ability to take a chip scale devices. As you can see here is the first chip device that has been engineered under ERC. This is a essentially silicon mixer that is being built jointly with the external faculty, being dropped into the setup here. The new piece about this is that we are not trying to build a setup around device. What we are doing, we are pipelining entire testbed processing facilities, piping this into this chip and taking diagnostics off the chip back into the testbed system facility to process, analyze and advance this work. This is the first of a chip supporting facilities. There will be a second one as we build out the ERC setup. And finally, I'm going to point up to the second workstation that has been now freed up for the participation from the ERC that is most likely going to satisfy Professor Cooper's participation in ERC. And at this point we will take questions. Thank you.